For this problem, we're going to use three different methods for dealing with quantifiers in proofs. The first one's called existential instantiation. You're going to have a given of the form there exists x such that p of x, and basically we are going to give a name of x naught to a particular value of x for which p of x holds. So we'll have a new given p of x naught. The second method we'll use is universal instantiation, and for that we will have a given of the form for all x p of x. And what this method allows us to do is just to say that p of a is true for any particular a that we desire. And in our proof, it's going to be the same x naught that we will use for our a. Finally, we're going to have to prove a statement of the form there exists x such that p of x. And for that, it is sufficient to prove p of a for any particular value of a that we like. And again, we're going to do that for x naught for our problem. So here it is. Prove that if there exists x such that p of x implies q of x is true, then for all x, p of x implies there exists x, q of x is true. So we have our given and our goal. And, well, actually, this entire statement is a big conditional goal, right? But I've already sort of done the first step here of taking the antecedent and bringing it over as a given. All right. So I've hidden the first step. The next step is we still have another conditional as a goal, and so we can do direct proof once again, bring the antecedent over as a given, and then from there we, well, whenever you have an existential statement as a given, it's a good idea to right away do existential instantiation. Okay, so give a name, for example x naught, to a particular x value for which the statement holds. So we have p of x naught implies q of x naught. And then for our universal statement here, we know that p of x is true for all x. The only x value we care about is x naught here. Okay, so we'll just say that p of x naught is true. And the reason I want to know that's true is so that I can do modus ponens here in just a moment. Before we do that, let's look at our goal. And to prove an existential statement like this, it's enough to prove q of x for a particular value of x. For example, x naught is what we're going to be able to do here. And so finally, modus ponens gets us from these two givens to our goal. Now we can try and write the proof. So remember, the first thing was to take this big conditional goal that we were given and to take the antecedent as a given. So we will say, suppose there exists x such that p of x implies q of x. And we're going to show that our new goal is over here. We will show that for all x, p of x implies there exists x such that q of x is true. And next thing was we had another conditional, so we once again did direct proof. Antecedent became a given. So we have another suppose for all x, p of x, and we show that there exists x such that q of x is true. And from there we had an existential instantiation to get this implication in terms of x naught. So I will write there exists some x naught such that p of x naught implies q of x naught, and it's by existential instantiation. All right, and then we had a universal instantiation to get p of x naught. So I can say because for all x, p of x, we know in particular that p of x naught is true. by universal instantiation. And finally, we did modus ponens to get our goal Q of x naught. So I can say because P of x naught and P of x naught implies Q of x naught, it follows that Q of x naught by modus ponens. And last but not least, our goal up here, the last goal we mentioned, was this existential statement. So we should just comment that we have indeed proven that by proving that Q of x naught is true. So I'll just say, therefore, there exists x such that Q of x, and that's true just because this last bit here, that's how you prove an existential statement, or it's one way to prove an existential statement. Okay, and that does it.